In this lecture, we will see all the basic concepts about the SCADA, why it is necessary, why it is important, and why it is reliable. So we will discuss all these concepts in these lectures. So introduction to SCADA. What is the definition of the SCADA? SCADA stands for Supervisory Control and Data Acquisition. It seems to be a system of software and hardware that allows industrial organizations to control industrial process locally or at remote locations, monitor, gather, and process real-time data, interact with the devices such as sensors, valves, pumps, motors, and more through HMI software, record events into a log file. What is the purpose? To improve efficiency, safety, and reliability in industrial operations. So this is a basic SCADA system architecture which is divides into four major fields. The sensors and actuators, and the other one is the RTU, SCADA RTU, and master level is the SCADA, and the operator level is the HMI. So that is all they are communicated through the communication networks. Four major levels that I have seen in the previous figure. The first one is the field level, where we see the sensors and actuators. Sensors measures temperature, pressure, flow, etc., while the actuators are valves, motors, and switches. Second is the controller level, where the RTUs and PLCs are used. So collect data from sensors, send commands to actuators, interface between fields, devices, and SCADA masters. Third level is the supervisory level, where the master terminal unit MTU is used, which is the main control system like computers or servers, perform processing, data logging, and visualization. The fourth is the operator level, which is the graphical interface for monitoring and control, which is known as HMI. And the other system block diagram of this SCADA is here, where you can see the control center, where the operator level and the other servers and the data systems are placed, and the second one is the communication level, and the other one is the field levels, where the sites, field site 1 is more like modem and PLCs are running, and WAN card, IED, and modem and RTUs. So this is also divided into three major parts, where the devices and the main control room are connected through the communication protocols. And communication is either through the wireless or through the switched lines or through the satellites. Like all the communication is possible through all these three areas. What are the key functions of SCADA? First one is the data acquisition, real-time data collection from field devices, data communication, secure and reliable data transfer over various media, monitoring and visualization, use of HMI dashboards to view system status and historical trends, control operations, manual and automatic control over equipments, alarm management, generate alerts for abnormal conditions, data logging and reporting, maintain historical data for analysis and regulatory compliance. SCADA system components in depth. What is RTU? It is remote terminal units, which is micro-based devices placed in the fields, communicate with the sensor and transmit data to the master stations. These RTUs will do these things. The other is the programmable logic controllers, PLCs. So more versatile than RTU, can be programmed for local control logic, frequently used in modern SCADA system. The operator level is the human machine interface level, HMI, which visualize interface to display real-time data and control elements. It allows operator to interact with the system. The last one is the SCADA server, which is mastered units. So that is central processor of the SCADA system, handles data processing, visualization, and storage. Communication infrastructure is basically the Ethernets, serial, wireless, fiber optics, satellite, etc. Communication in SCADA, communication media, wired or wireless. If it is wired, you can use Ethernet or serial or the fiber optics, but if it is wireless, you can use radio, cellular, satellite, or Wi-Fi. What are the communication protocols used? Modbus, RTU, TCP, which is simple and widely used. DNP3, common in electrical and water utilities. IEEE 60870-5-104, used in Europe, especially for power systems. OPCUA, platform independent protocol for secure communication. And what are the challenges? There is data latency, interference, and cyber security, that we don't want any delay in the data. If there is an interference, our data should be secure from the cyber security threats. Application of SCADA. Industrial examples. First one is the energy, like you can monitor power plants, electrical grids, and solar farms. The other example is the oil and gas, where the pipeline monitoring, like if there is any leakage detection, or refinery automation. Third one is water and wastewater. You need to take the tank level control, pump monitoring, and chemical dosing. The other one is the transportation, traffic control, railway signaling, airport baggage system. And then manufacturing, assembly lines, quality control, robotic system. What are the advantages of SCADA? Real-time monitoring is possible, like immediate visibility into process variables, reduced downtime, early detection of faults, and fast troubleshooting, which is the basic requirements. Remote operations, like you can control while sitting over a large distant locations, or it can be a centralized locations. Data logging, historical trends, analysis for optimization, like you have all the previous data available which you can use for the analysis or for the optimization. Improved safety, automatic shutdown in the hazardous conditions. This is a very big advantage of these SCADA systems. Scalability, can expand to accommodate new systems. Challenges and limitations. First one is the cyber security. SCADA systems are vulnerable to hacking and malware if not protected. Initial cost, expensive to set up and configure. Complexity, requires specialized skill for setup, maintenance, and troubleshooting. System integration, difficulties in integrating legacy and modern systems. Data overload, large volumes of data may require filtering and analysis tools. What are the modern trends in SCADA? Cloud-based SCADA, like centralized data which is accessible from anywhere and easily scalable. IoT integration, smart devices enable better automation and monitoring. AI and machine learning, which is also very useful, which is predictive maintenance, anomaly detection, edge computing, data processing closer to the source for faster response. Mobile access, use of smartphones and tablets for real-time control. Conclusion. So what have you learned from this lecture? That SCADA systems are critical for efficient and safe automation. They provide centralized control, real-time monitoring, and historical data analysis. And with the rise of IoT and AI, SCADA systems are becoming smarter and more connected. Thank you for watching these lectures. I hope you have understand the basics of the SCADA system, why it is necessary, what are the applications, and if you still have any questions, you are most welcome to ask in the comment box. Thank you.